2 of the Game of Thrones. On this episode, nobody died. Instead, we try to think about how to live, how to win, and end up perhaps on the Iron Throne. I think that's what it's called, right? Yeah. So the question that we posed today was, how can you make sure to always win if you are first? Which games could you always win if you are the first person to play? So we started with what people remembered about the game to see if that would help us. So people kind of overwhelmingly said that it was good to be an odd number at first because all the even numbers died right away, first round. After that, being an odd number doesn't necessarily mean that you're going to win. So like being odd is good at first and then not so good necessarily. Additionally, your placement determines whether you're going to win. The game is rigged in such a way that there is one best place to stand. It's not random. And that is dependent on who went first. So we're going to apply that to being that person to go first. And the way people really most effectively started approaching it today was if they just started small, started with a simple case, and started looking at different cases that they had. So this resulted in people doing lots of drawings. And I'm not going to draw out what that looks like because you can go back to yesterday's to see what drawing a game of Game of Thrones might look like. I think what ended up being most effective was to start listing out the ones that worked and the ones that didn't work. And so, one wins and one's where person one loses, the person who starts with the ball. So you could start with a game of one person, but that's not really a game. You've already won at that point. So let's go to a game of two people. The person who has it has to skip over the other person, goes right back to them. So in a game of two people, person one is going to win. In a game of three people, if we were to continue trying other cases, person one does not win. They die. In a game of four people, person one wins. So people started wondering, is this an even and odd situation? 2 and 4, person one is winning. In 3, they're not. So they started trying some other odd numbers. I had some teams like Michaela and Mikayla who decided to try a bunch of odd numbers. They tried like 5 and 5, they lost. Person one lost. They tried 7 people in the circle, lost. Tried 9 people in the circle, lost. So it seems like it might be even numbers. Even numbers of people in the circle. So they said, all right, well, 2, 4, let's try 6. Turns out, when you do 6, 6 also is not good for the starter. So if our conjecture or our claim had been that it's good with an even number of people, that claim is no longer going to hold because we have the information that it doesn't work for 6. So I kept trying other things. We found that 8 worked, found that 12 did not. With some classes they thought 12 did, especially if they were going with this evens. So then people thought maybe multiples of 4. But finding that 12 didn't work kind of messes that one up, and this is perfect. This is what you do. You come up with a claim and then you see if you can counter it, if you can refute it. So 12 doesn't work, so it's not multiples of 4, but 16 works. So 2, 4, 8, 16. In 7a, they noticed something about this. It's related to multiples of 2. It's related to multiples of 4, but it's neither of those things exactly because other things that are multiples of 2 and multiples of 4 don't work. But if you have it organized clearly like this, and you can go kind of down the row, down the line with more cases, people started noticing, well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So by that reasoning, our next one that the first person would win is 32. So in order to be sure, you could go and check that. But if that works, that would be a pretty good sign that you found a pattern of what games are going to lead to person one winning. And in fact, 32 does work. If you go through and test it, you can see that 32 does work, which leaves you with the need to turn this into a claim, this pattern. We're going up times 2, times 2, times 2. What kind of thing involves doing times 2, times 2 exponents? So 2 is just 2 to the first power. 2 times 2 would be 4, and that's equal to 2 squared. 8 is 2 times 2 times 2. 16 is 2 times 2 times 2 times 2, so on and so forth. So it turns out that in order for the first person to win, the number of people in that circle have to be a power of 2. And that's an interesting thing to find. And that, because we started with some simpler cases and solved simpler problems, we were able to, and then organized it in a way where we could look at the things that were working for once, we were able to find some patterns that let us generalize further and test some conjectures and then find a conjecture that works. So the Game of Thrones is over. I invite you to get some games going, see if you can maybe, I don't know, put some money on it or something. Don't do that, don't get me in trouble. And play. Now you have some ideas about how to be the winning first player. Question is, what if you don't start? And I'm going to leave you with that. Good night.